Hey everyone, today we're going to talk about equations with variables on both sides. So sometimes we have variables that are on both sides of the equals sign, and we got to figure out how to manage that. So this was a section that's got an awful lot happening in it, so we're going to actually do two different notes for this one. I'm going to stop about halfway through this one, and next week's video will be on the second half because they're kind of two big things that we want to make sure we understand. So what is the difference between this type of an equation that has a 2x, an x, and a 10, and this one that has a 2x, an x, and a 10? Well, obviously they have the same exact terms, but looking at here, we see that we have x's on both the right and the left-hand side. So we got to figure out how to manage that so that we can still solve for the x. So when there are variables on both sides of the equation, you must move them by either addition or subtraction until all the variables are on one side and all the numbers are on the other side. Then we can solve using SADMEG and using those steps to use the inverse operations to move all the other things away from the variable we're solving for to get our answer. So our first step is going to be get the variables on the same side. Now it doesn't matter which side you put them on. That's going to be a little bit of a preference to you. What I would try to do is get all the variables to one side with as little as possible to move after that. But again, it won't matter as long as you follow the steps correctly. Once the variables are all together, then you just use your SADMEG to use all the opposite operations to move things away from the variable to get your answer. So here's our first example. So we want to solve this equation. So what I want to notice right away is I'm trying to solve for x. But notice I have x's on the left and the right. So here's what I would do on this one. I'm still going to kind of draw my line here. I want to notice that the line tells me that anything that crosses that has to be using the inverse operation. So I see x here and I see x's here. So I'm going to take the minus 2x and I'm going to add 2x to both sides of my equation to get the x's to move from the left side to the right side. So the negative 2x plus x will cancel, leaving me with a 15. On the right-hand side, negative 7x can be added with 2x because they're like terms, and a negative 7 plus 2 is a negative 5x. So now I can see that all the variables are together on the right-hand side. So now I switch into SADMEG mode, and I have to just undo what I see. So I see one operation, so that's easy to know which one to do, and the operation is 5x, or negative 5x, which means multiply. So I know the opposite of multiplying is to divide. So what I'm going to do is say divide both sides by that negative 5. That will cause that negative 5 to cancel on the right-hand side, and that will give me the x that we're looking for. And on the right-hand side, 15 divided by a negative 5 is negative 3. Now again, just like we said in the last couple of sections, you should always check your work because that's going to tell you if you have the right answer or not. And to remember, we check our work with the original equation. So I would go back up top and I'm going to say 15 minus 2. But now instead of writing an x, I'm going to plug in the negative 3 because that's what we think it is. And remember, I'm plugging it into the original. Again, negative 7 times x is now a negative 3 because the original is the one that's going to be no mistakes. Once we start doing things, we might have made a mistake. So now that I've plugged in the negative 3 for x, remember when I have all numbers, that's when we go with our regular order of operations, so I would follow GEMDAS. SADMEG if I'm looking for a variable. If I have all numbers and operations, it's GEMDAS. So with GEMDAS, I would then be doing the multiplication here and also on that side. So the 15 is going to wait. negative 2 times a negative 3 is a positive 6. And over here, negative 7 times a negative 3 is a positive 21. And then obviously I have one operation there to say 21 on the left side. Does it equal 21 on the left side? It does. So don't get tricked thinking my answer is 21. It comes back to this other thing over here where we said we thought the answer was a negative 3. And the negative 3, when I plug it in, does work. So x equals negative 3. The only other thing that typically we would like you to do is not leave it as negative 3 equals x, but to spin it around just to say x equals negative 3. Both of those answers are fine. Ideally, though, we'd like to see the variables solved on the left-hand side as our final answer. Now, moving on to the next one. So remember this thing, distributive property, that you worked on last year. So with distributive property, we first have to do some breaking up of that grouping. We can't just start doing things like we did in the previous one. So the very first thing I have to do is use my distributive property to kind of get through the left side and the right side, combine any things that we can, and then see where we're at. But it does look like I have variables on both sides here, so I'm probably going to have to move them over after I've broken up these groups. So if I break up the first one, I'm going to have negative 2 times x, or negative 2x. Then I go back outside and say negative 2 times a negative 5 becomes a positive 10. Over on the right-hand side, I see 6 times 2, which is 12. And I see 6 times a negative 0.5x, which means negative 3x. So we can now maybe see it even clearer that we have x's on both sides. This is where I first, before I start using my SADMEG steps, want to get those variables together. Now this time what I'm going to do is I am going to add the 3x to both sides. On the previous one I used the left side and added them to move them all to the right. This time, the reason I'm going from the right side to the left is because I can see this right away, that when I do a 3x and a minus 2x, I'm going to have a positive number of x's. So it's a personal preference. You certainly don't have to do it this way. You can just always add them always to the left or add them always to the right, and you'll still get the same answer if you follow everything correctly. I just try to find something that's going to make my life a little bit easier. Getting positive x values to me is a little bit easier, but it's certainly not something that you can't do the other way. So the negative 3x and the positive 3x will cancel each other out to become 0. On the left-hand side, that negative 2x plus 3x is a positive 1x. Remember, that means 1 in front of that x. Bring down what hasn't been dealt with yet. Now again, if I'm solving for x, I need to subtract the 10. So again, the 10 needs to be subtracted from both sides, which is going to leave me canceling with the 10 and the minus 10, or negative 10. And then I get x equals 2. Now here again, this would be a good one to be checking just to make sure we haven't made a mistake someplace. So when I do my check, negative 2 times, now the x becomes a 2 minus 5 equals 6 times 2 minus 0.5 times 2. So remember again, the x changes to the value of a 2. And again, now I'm switching into GEMDAS mode. So I'm going to take care of the groupings first this time. So inside my groupings, I get negative 3. Inside this grouping onto the right side, I first get 2 minus 1. The 6 and the negative 2 just come down. I would stay inside the grouping to get 6 times 1. Over here, negative 2 times a negative 3 is a positive 6. 6 does equal 6. And again, the answer is not 6. Don't get caught thinking that. It does check. But it checks when x's go in as a positive 2. So I know that that is the right answer. So I'm going to pause right now. That'll be the end of the part 1 part of this video. The note sheet that you have continues on, and next time we see this video, it'll be part 2, and we'll pick up from example 3. So again, work on these, let me know where you have any issues or questions, and we'll be practicing these in class, and certainly make sure that you ask where you need some help.